Welcome everybody to my talk about Qt Multimedia in Qt 6.2. Here's a short overview over what we're going to be talking about today. We'll start off with a little bit of an architectural overview, look at the different functionality blocks that we have in Qt Multimedia, what has changed from 5.15 and why we've changed things in the architecture there. Then we'll go over to device discovery, looking at cameras, microphones, headsets, a quick look at our low-level audio API and audio decoding API. We'll have a look at how Playback works and how you can make use of that. And then go into recording and capturing of audio and video before I'll end up with an outlook of what's going to happen after Qt 6.2. Let me start off with a quick sentence and a statement that Qt Multimedia is the one API where we've made significant API changes from the previous version that we provided in Qt 5. And there's a couple of reasons for that I'll go into in the next slides. Qt Multimedia in Qt 5 was suffering from an overly complex architecture. There were multiple problems in there. We, for example, had a public backend API that didn't allow us to, or made it very hard to change architectural things and change implementation details on the backend side. There was a complex plugin infrastructure for those backend APIs where different plugins were responsible for different parts of the functionality. So you could have, for full multimedia support, you could have 4 to 5 plugins that we needed to instantiate and load at runtime. And that made it also rather impossible to offer a consistent front-end API. The API was also rather video-centric. Audio-only use cases were not that well supported. For recording, the camera was a central place for capturing, making those audio use cases rather difficult. We also had a lot of problems in getting to a consistent support of the functionality and the APIs that we offered across all our supported platforms. And that goes back a little bit to some of the problems we had with the public backend API and other things. Finally, we were suffering from rather large inconsistencies between the C++ and the QML APIs. Certain functionality was only offered in one of the two, and they were very different from each other. So to fix that, we went and made some rather large architectural changes with Qt Multimedia in Qt 6. The first thing we did was to remove the plugin infrastructure and the plugin architecture. We're now selecting the backend, the platform APIs that we're integrating with and that we are using to render video and record video at compile time. We're also implementing only one backend for all of multimedia, and we don't have different plugins for different parts of the API for different features. This is rather similar to what we're doing with our QPA infrastructure in Qt GUI. We made the backend private API to be more flexible and avoid any login and compatibility issues as we had in Qt 5. That allowed us also to avoid a lot of code duplication between the front end and the back end, and we could significantly reduce the amount of backend classes that somebody needs to implement to create a new backend, down from 40 classes that we had in Qt 5.15 to 15 in Qt 6. Finally, those changes also allowed us to share more code across the different platforms and implementations. We also have in Qt 6 now a shared API and implementation between C++ and QML. That makes it a lot easier for you to navigate things, especially if you're using both. You only have one API you need to learn and to remember. Altogether, those changes significantly also reduced the complexity of our code base. Where we had 150,000 lines of code in Qt Multimedia in 5.15, we're now down by 50% and have around 75,000 lines. That cuts the complexity in half and the things that we have to, the amount of code that we need to maintain in half, allowing us to move faster, implement new features and new functionality faster. And I need to note that this change in the complexity was done without compromising a lot on functionality. Qt 5.15 does not offer more features than Qt 6.2. Quite the opposite. In some cases, we managed to add new functionality to Qt 6.2 that was not available in 5.15. As said, we are basing Qt Multimedia on an underlying platform API on the different platforms. And for that, we're using GStreamer on Linux. We're using AV Foundation on macOS and iOS. We're using the Windows Media Foundation classes and frameworks on Windows, and have a native Android backend as well. Let's have a quick look at the high-level architecture. There are mainly 5 large functionality blocks that we have inside the Qt Multimedia API. We're having a set of APIs around device discovery, knowing what kind of cameras, what kind of audio devices you have attached to your system. We have a low-level audio API for playing back and recording PCM audio data and decoding audio into PCM data. We have a more high-level playback API for audio and video using the QMediaPlayer class or the MediaPlayer QML API. And then a large set of classes to record audio and video and still images. And finally, the last block, and I'm going to talk about that one a bit as well, is our video pipeline. How we manage to have a fully hardware accelerated pipeline from the decoding phase all the way to bringing things on screen. But let's start off with a low-level audio API a little bit. Here you have a low-level API that allows you to open an input or an output device and write PCM data to it or read it from it. Those classes are called QAudio Source and QAudio Sync. For those of you who have used Qt 5, those are the classes that were named QAudioInput and QAudioOutput in Qt 5. We did some API changes and class name changes here because we wanted to use the more generic QAudioInput and QAudioOutput name for something else. We'll come back to that later. We've simplified the handling of PCM formats using the QAudioFormat classes, and we're supporting 4 different formats right now: 8-bit unsigned integers, 16 and 32-bit signed integers, and 32-bit floating point PCM data. QAudioFormat also supports positioning information for the audio channels, something that is not yet hooked up to the backend. We have that in the front-end APIs, but that will come in subsequent releases. We also have an audio decoding API. QAudioDecoder is a class, and that existed in Qt 5.15 but is now supported on all platforms, where in 5.15 it was only supported on 2 of our platforms. It allows you to decode audio files into memory buffers and can be used together with, for example, QAudio Sync to decode encoded audio data and then stream it into an audio device. Audio encoding of PCM data is not currently supported in 6.2, but that is not something we had in 5.15 neither. The next functionality block is device discovery. How do I find out what kind of cameras, what kind of audio devices I have attached to my system? The QMediaDevices class handles that for you. You can use it to list audio inputs and audio output devices. You can list the cameras that are available, and it also supports dynamic detection of device changes. For example, if you at runtime of the application attach a new headset through Bluetooth or USB, we will notify the application of that change through a signal coming from QMediaDevices. So here's some code snippets. You can basically list all your cameras using QMediaDevices available cameras. And then you can also connect to the audio input's changed signal to get notified whenever an audio input gets removed or added. And you can then react to that accordingly in your application. Playback is supported through the QMediaPlayer class. That class is still relatively similar to what we had in Qt 5.15. But there are some changes that we have been doing also here. One of them is that you will need to explicitly connect audio inputs, audio and video outputs to the media player classes to be able to play back audio and video. You can select those devices at runtime. You can also let it select the default output for you in an easy way. I'll show that in a minute. But you have to connect those outputs explicitly. The reason for that is that we wanted to make sure that the API is symmetrical between audio and video and between C++ and QML. And that made it possible for us to achieve that. QMediaPlayer also allows you to read the most important metadata of an audio or video file, like the author or title information. And we added support now for selecting of different audio, video, and subtitle tracks, added support for subtitles there, with the exception of Windows, where subtitles are not currently supported by the Windows Media Foundation framework. But for each track, you can query the track metadata, like the language information, to be able to offer the user a choice of what they should be selecting. Here's a C++ example of how you can create a media player for playback. You just create a QMediaPlayer, an audio output. We're using the default here. We create a QVideo widget to render the video and connect the audio output and the video widget to the player. Set a source file, like just some MPEG-4 video, and then we call play on the player to start playback of that video. In QML, this looks rather similar. We basically create a video output inside a window. Well, let it fill the whole window. We instantiate a media player object here as well, connect an audio output to it and connect the video output to it, set the source to the video that you want to play back, and then once we're done loading all of those components, we just start playback automatically here. This here shows our QML-based media player example. It's slightly more complex than the code I've showed before, but it showcases a lot of the functionality that you can have in the media player and that you can use with the media player. I've already loaded a small video file here and you can see how it's running. You can change the playback rate to something very slow or something very fast and go back to normal. You can also see that you can seek here. And you can already see that we have the subtitle support available here. Something where you can easily change also the subtitle language. For example, you can switch over to Japanese here. See the Japanese subtitles, or something in Spanish, where we then have the subtitles in Spanish. Let's now move on and have a look at how to capture and record audio and video. This part of the API is the part that has changed most since Qt 5. The central class now to govern and handle all the capturing of audio and video is called QMediaCapture session. QMediaCapture session is the class that governs all of it and steers the whole session. And you can connect a camera and an audio input to that session, as well as then connect something to preview and monitor and an audio recorder to record audio and video content. Or you can also add a QImageCapture object for taking pictures. That's very different from what we had in Qt 5.15, where the QCamera class was pretty much the central class that you had to instantiate to record anything. QAudioInput and output are new in Qt 6, and they represent an input or an output channel. You can set the physical device that you are using on that channel using setDevice. By default, if you instantiate in QAudioInput or QAudioOutput, it will use the system's default device by default. So if you just create a QAudioOutput and connect it to a media player using set audio output, it will use the default output of the system. But you can also select a different output channel, output device, by basically querying QMedia devices for the available outputs and then selecting a different one of those devices. QCamera acts similar to QAudioInput as a channel, and you can assign also here a physical camera using set camera device. Also here by default, if you instantiate a QCamera, it will use the system's default camera. QCamera offers a large and flexible API to control various properties of the camera device. You can set the resolution that you'd like to have, the frames per second, exposure times. You can enable and disable flash or torches or backlight modes, depending on whether the camera supports that or the device supports that. Exposure times, ISO sensitivity, and all of those properties can be set on the camera. But as to remember, it's not the central class as in 5.15. It basically only controls the camera properties itself. And QMediaCapture session is the class that's controlling the whole capture process. You can then also combine that with a QImageCapture object to capture still images. So take a QImageCapture object, basically connect that to the media capture session, and then capture still images. You can see a code sample here where we basically instantiate a capture session. We instantiate a camera, add it to the capture session, instantiate a QImageCapture class, also add that one to the session, start the camera, and then we're ready to capture an image, for example, by saving it, capturing it to a file. Or you could also capture it to a buffer, meaning that you will receive a QImage inside the application that you can then use as you like. The other option is, of course, to capture audio and video, and that is done using the QMediaRecorder class. That one records audio and video from a capture session, and of course, depending on what you have connected to it. If you don't have a camera connected to the capture session, the recorder will record audio only and no video. You can specify the settings for the encoding there using QMediaFormat. I'll come to that in a second. That one basically governs file format and codecs. You can set the quality, the output location, bitrate, and so on. Here's also a small code example where you instantiate a MediaRecorder. You set that one as the recorder on the capture session. Set the output location to, for example, mycapture.mp4, and then you say record to start the recording. QMediaFormat is a class that specifies basically the media file formats and the codecs to be used. It offers an enum-based API, not something that's string-based, and that's a larger change from Qt 5. The reason for that is that with an enum-based API, we can actually offer a nice cross-platform API. The API in Qt 5 was string-based, and the strings were very different between different platforms. You can query the supported formats from QMediaFormat, and QMediaFormat will also automatically resolve a format for recording to something that is supported. So here's an example where you specify, for example, that you would like to create an MPEG-4 file with AAC as the audio codec and H.265 as the video codec. Let's have a small look at an example, a QML-based example here this time, where we also again instantiate a window. We create a capture session with a camera where we use just the system's default, an audio input so that we also capture audio. Also here we use the system's default audio input. We create a video output element to see a video preview of the video that's being captured. Connect that one to the capture session. and we create a media recorder that we also connect to the capture session with a specified output location. Then, once we're done loading the component, we can start the camera and start the recording. And we could add a button easily that will stop the recording when the user clicks on it. Here you can see the QML-based recorder example that shows you some of the possibilities that you have when recording videos using a QMediaCapture session in Qt 6. It shows you, for example, that you have options to select different cameras at runtime. You can select a different microphone to capture the input. And you can also specify different settings. You can, for example, specify the quality of the encoding, the audio codec that you want to use. For example, I want to use AAC, the video codec. You also see here that you only see those codecs that are supported by the platform. So in this case, I'd like to have H.265, for example, and MPEG-4 as a file format. In addition, I can add some metadata, for example, the title, here we go, and get all of those recorded. Then I can simply go in and start, press the record button to record the video. Let's have a look at the video output pipeline. This is also a part of Qt Multimedia that has changed significantly between Qt 5.15 and Qt 6. The central class that handles things from a public API perspective is QVideoSync. This class handles the connection between a video output surface and the backend that generates the video data. It delivers video frames from the backend through the video frame changed signal. The output surface can be any Q object. All it needs is a Q-invocable QVideoSync property. Qt provides two standard output surfaces in Qt 6.2. QVideoWidget for QWidget-based applications and the QML video output element. But you can also create your own surface if you so choose, or use QVideoSync directly and connect to the VideoSync frame signal to do something with decoded video frames yourself. QVideoFrame is the class that you then need to use. It represents one frame of video data and supports a wide variety of formats, both YUV and RGB based. It also supports a fully hardware accelerated pipeline for QVideoWidget and the QML video output element. Currently, Windows still requires one copy in software, but we're working on eliminating that one as well during the 6.2 patch level releases. Any QVideo frame can also be converted to a QImage using the QVideoSync toImage method. So you can handle that image, use it yourself, and use it for your own purposes. You can also always render a QVideo frame in software using a QPainter to any surface or any object you like. On the hardware side, we support mapping of video data to memory, so you can map the raw video data, and we support also both planar and non-planar formats. Finally, the video frame also gives you access to the current subtitle text, so you can use that information to render some subtitles somewhere. Here's a small example of a slightly more advanced use case showing how you can combine Qt Multimedia with Qt Quick 3D. We basically create a window and then put a rectangle in there that's actually not visible, that contains the video output element. We add a media player that connects to the video output element, and then use Qt Quick 3D to create a view 3D with a camera and a cube model, where we basically use the output of the video element, that layer that we create there, as the texture for the camera. And here you can see how this would then look if you also add an animation to it that rotates the cube. You can see the video played back on all faces of that cube. This basically completes the overview over the different functionality blocks that we have in Qt Multimedia and Qt 6.2. I'd like to add a note around the QML API that we've developed for Qt 6.2. The API exactly mirrors the C++ API. They're actually co-developed and use the same code base, which means the same API works for both QML and C++, and they're also tested together. The design decisions that we've been doing when developing the C++ API were actually driven also by the fact that we wanted to use that one for QML as well. So there are no QML wrapper classes for any of the API, with the exception of the video output element, as no C++ equivalent exists in this case. A quick recap and showing some of the delta to Qt 5.15. There's a few things that we have removed. Spatial audio is one of them. That was the audio engine QML API. It was only available in QML. This is something that we're planning to reintroduce in a hopefully better way for a future release, where we're also looking into integrating that with our 3D engine, with Qt Quick 3D, and see how we can do that. Custom GStreamer pipelines was a feature that was used in some cases in 5.15 to work around limitations that we had there. It's a feature we removed because it's very hard to maintain, and we'd rather like to hear from you for the use cases where you needed that feature, and then try to find a way to support that fully in Qt Multimedia directly. There were also custom video node plugins that were available in 5.15. They were rarely required, just to solve certain special use cases on special embedded hardware. And we believe that those are better solved in Qt Multimedia in the library directly. At the same time, we've added a couple of new features and functionality. We can dynamically detect changes of the device configuration that are attached to your system. We have language selection and subtitles on Playback. We have a cross-platform QAudio decoder API that works everywhere now. We have an audio monitoring channel when capturing and recording media that didn't exist in 5.15. The codec and file format handling has improved and is much more cross-platform nowadays. And we have a fully hardware-accelerated path for both QML and widgets available now. As I mentioned earlier, Windows still needs a little bit of work, but we aim to get there within the 6.2 patch level releases. And the hardware accelerated path also might require a little bit of additional work on certain embedded platforms. There are a couple of new features that we are also planning after 6.2, where QNX support is one of them, as one of the platforms that we had in 5.15 that's still missing. I mentioned spatial audio. We'll be looking into that. We want to support screen capturing and recording in the future. Capturing of multiple audio and video streams simultaneously would also be very nice to have. Supporting multiple audio and video outputs simultaneously for playback. And then in addition also being able to support programmatic inputs for both audio, video and subtitles, and maybe some mixing APIs. But those are long-term things that we will not have immediately available in the next minor releases. These are things that will evolve over the lifetime of Qt 6. Well, with that, I'm at the end of the talk. If you have any more questions and would like to ask those, I'm available in the speakers lounge after the talk for the next 30 minutes. Thank you very much.